Nuclear transformation. On our early topic, we learned about when a nucleus being unstable, it will give out alpha particle or beta particle or gamma emission. Now we're going to turn around, look on to how I'm going to make a nucleus unstable. That is to call nuclear transformation. We do it by two ways. One is called to bombard it with a charged particle. Another is called bombard with neutron. And this is what we're going to go detail. Transuranic element. Transuranic element is element followed after uranium in the periodic table. Uranium itself is the heaviest element occur naturally on Earth. So, those transuranic elements must be created synthetically. So they are not natural. They are made through the laboratory. Back into the 1940s, Napoleon and plutonium, they first created by synthetically made through the laboratory. And then in following the after. And how now we're going to talk about how these transuranic elements being made. Of nuclear transformation, there is two ways. One is called bombard with charged particle, another called bombard with neutron. Let's start off with bombard with charged particle. Bombarding with charged particle. Bombard with charged particle against the nucleus so that you can make it into a new element, this new radioisotope. But there is a problem because this positive charged particle, if you shoot it against a nucleus, also nucleus is made of positive proton and a neutron. So positive will repel the positive. So you will never succeed to shoot a positive against a positive. So in order to overcome this problem, because you have to overcome this electrostatic repulsion between this positive charged particle and the nucleus. Then how are you going to achieve? First, you have to shoot it in a very, very high speed. You have to shoot it at a very high speed so that to make this particle to combine into the nucleus. So you must be accelerate to very high velocity. So there is two types of accelerator. One is called a linear accelerator, but Australia we're using the cyclotron. And now we're going to talk more about cyclotron. So let's explain what's meant by bombarding with a charged particle to create new isotope. What does charged particle mean? If you look on the periodic table, let's choose any small atom. Let's take carbon. Do they have charge? No. 6 proton, 6 neutron with 6 electron. The charge are balanced. No charge. But if I remove the 4 outside electron, now what will happen? They become 4 positive. They become a charged particle. Now, with this charged particle, I'm going to shoot this charged particle to my target as the following 3 examples. So on the first one, you bombard this hydrogen 2 against the MO, to make it into a new particle, TC99, and with further emission. Another example, you shoot it with another charged particle, proton. How do you represent proton? One mass and one charge, hydrogen. It is a proton. So you shoot it onto a carbon-12 to make into new element. The third example, you shoot it with an alpha particle. How do you represent alpha particle? He, helium, if you remember on last lesson. Mass 4, charge 2. You shoot it onto aluminium 27. Now it formed into a new particle. So these three are the example. And you will see sometimes they will shoot out, besides of the new product, they will also shoot out an emission. Sometimes they will shoot out an emission, but sometimes they don't shoot out emission. This is all done by experiment. You cannot predict just only by the equation. So this is by experiment to decide. And this picture is the Australian medical cyclotron in the Sydney Royal Prince Alfred Hospital. How does this work? Now let's pay attention. They have a tank, and this tank is the accelerator. Now let's see. This particle accelerator, remember, we have to increase the speed. And so they will have two disks. So they're using this alternative electromagnetic field to make the charged particle speed up to a very high speed so that you can shoot the target. Here you can see the top is negative, the bottom positive. Now it can change, and it can change very quickly. When you put a charged particle in, this charged particle will repel by positive and attract by negative, as follows. Now they change the charge again. Now they will attract to the top. Now they change the charge. They change the charge. They change the charge. And change the charge. This way, they can increase the speed until fast enough and to shoot the target. So this is the particle accelerator, how it works. Now, there is a second way of bombardment. This is called bombard with neutron. To bombard with neutron, where's the source of neutron you come from? You need to using the nuclear fusion reactor. Why we using neutron? Neutron have one good advantage. Neutron have no charge. If neutron have no charge, so this particle that you're shooting, you would not repel by the nucleus. So in that case, it saves you to making an expensive accelerator to increase the speed. You don't need to. Then you can be on a normal speed and it can work. Because as they say, neutron have uncharged, they won't experience this elastic repulsion force. So And the bottom picture is this HIFA reactor, this nuclear fusion reactor. Now we see how can you tell from the equation this is bombarded with charged particle or bombarded with neutron. Here you can see this target you combine with a neutron. Neutron, the mass is 1, the charge is 0. Neutron have no charge. So that is the way to, when you look, you see this, you represent this is a neutron bombardment. And this happened to all the neutron-rich isotope that I'll go detail later. Now let's see how this neutron work. And where did you get the neutron from? They choosing the uranium. What's special about uranium? Uranium is a reactive element. This is bigger than 83 and they are reactive. Another element, uranium, they are big and have a lot of extra neutron. When a uranium, they break up by fusion, they will break up with alpha emission into smaller particle and also will emit a lot of neutron. So when the neutron, this uranium, they break up inside the nuclear reactor. If you put your target next to it, now this target become the receiving end of the neutron. So this is the neutron bombardment. So you put the sample inside the nuclear fusion reactor to receive the neutron fusion. That's how it made. Of these two types of isotope making, that is different. The top one, they making neutron-rich isotope. That is created by nuclear reactor. The bottom one, they making neutron deficient radioisotope. This created by cyclotron. How? Imagine on the top, your target, you keep on shooting more with neutron, with more neutron, with more neutron. What will be the target become? The target will become too much neutron, neutron-rich radioactive isotope. The bottom one, if you shoot the target with charged particle, positive charge, with more positive charge, with more positive charge, what this target will end up? It become too much positive or not enough neutron, neutron deficient radioactive isotope. So they will make two different types of radioactive isotope. The top one, done by nuclear reactor. And take some example. Cobalt. Cobalt should be 58. You got a cobalt 60. Too much neutron. TC. TC should be 97. You got a TC 99. KR 83. You got a KR 85. Too much neutron. Iodine should be 126, stable. Now you got a 131, extra neutron. So they are those radioactive isotopes, they are neutron rich. too much neutron, and being unstable. The bottom one. Let's look onto those neutron deficient radioactive isotopes done by cyclotron. Look, carbon should be carbon 12. You got a carbon 11, unstable, too little neutron. Nitrogen should be 14, stable. You only got nitrogen 13, too little neutron. Oxygen should be 16, stable. You only got oxygen 15, unstable. Iodine should be 126, stable. You got a 123, too little neutron. So now they're making two different types of radioactive isotope by two different machinery. Now let's go on to the equation. Try the first one. Uranium undergo alpha decay. What will be the product? How to write alpha decay? This is alpha. What will be the product? This is the product. Next question. Carbon 14 undergo beta decay. How to write beta decay? What's the product? Nuclear transformation. First question. Can you work out what's the product? T2 plus 1 give 43. 43, you look up the table, is a TC. 98 plus 2 give 100, minus 1. This is a TC 99. Next question. What's the product? What's the name? Nitrogen 13. Next question. What's been bombarded with? Alpha particle. Next question. How to write neutron? Thank you.